Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Cece.
And I'm Harrison. For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email is dothemath@kern.org. We're online at dothemathonline.net and on social media, Facebook, Instagram, Twitter, and YouTube.
All right, Harrison, thank you for that. So where do you attend school and what grade are you in?
I attend school at Stockdale Elementary and I am in 5th grade.
Have you been at Stockdale for a long time?
Yes.
For all of your schooling?
Yeah.
Okay, so you've been there for a long time. So Stockdale ends at 6th grade, correct?
Yeah.
So what do you think, because you've been there for a while, what do you think one thing you'll be missing when you, after next year? What do you think you'll miss about being at Stockdale? Because you've been there at least half your life, right? Because you're in 5th grade, you've been there 6 years, and you're not 12 yet, right? So
No.
you've been there more than half your life. So what do you think you'll miss about that school?
All the teachers are really nice.
Well, good. So you've had a good experience with your instructors. Excellent.
Yeah.
How's 5th grade going?
It's good.
Could it be better?
Yeah.
How could it be better?
A lot of people say the other teachers are better, and I also probably would agree.
You know what? Are you learning a lot?
Yes.
Are you having fun while you're learning?
Yes.
What do you think you go to school for?
Education.
There you go, right? And then because you can do stuff with your friends all the different times and stuff like that. In 5th grade, are you able to do anything other than just go to school? Like, are there extra things like chorus, band, sports, any things like that that you guys are able to do, or events like science fair and things? Or
Yeah, we have science fair, band, chorus, basketball, football.
is there anything that you do yet, or are you just kind of hanging right now?
I'm trying out for the basketball team
Oh, good.
and doing band and chorus.
Oh, good. All right. So you're in band,
Yeah.
and what do you play?
I play trumpet.
All right, cool. Do you know anybody that has played trumpet before, or you're the first one to go?
No, a lot of my other friends did too, and my grandpa did.
Oh, good. Okay, so your grandpa did. All right, good. Well, that's nice that you're playing trumpet in the band and doing chorus and going out for the basketball team. You ready to do a little math? I think that's what you're here for today, right?
Yeah.
All right, let's take a look at the social media problem of the day. It's going to be up here on the board. It says, what is the value of the underlined digit? So first of all, what is that number that we're looking at up there? Can you read that for me?
0 and 921 thousandths.
Good. So you read that perfectly, because a lot of students would go 0.921, which is another way to read it. So what do they want us to do?
Find the value of the underlined digit.
And the underlying digit is?
1.
All right. So the way you read it probably already has your answer, but do you know what the value of that is?
1,000th.
So it's 1/1000th, correct? So out of the options that we have up there, which ones can we eliminate immediately?
B and C.
Good, because it doesn't even have thousandth in it, right? They're already written out in word form, so we can get rid of B and C. Which one do you think it is, A or D?
A.
So why not D?
Because it is in the hundredths place, not the thousandths place.
Okay, so you're familiar with place value as far as decimals go.
Yeah.
All right, good. So you're willing to go that it's 1 times 1/1000th?
Yes.
You feeling pretty good about that, huh?
Yeah.
Real good?
Yeah.
All right, let's find out if Harrison is correct with A. There you go, nicely done, dude. First problem out of the way. All right. 636-4357 is the phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout most of the school year. Time now for today's Math in the News. All right, today's Math and News has to do something that you are very familiar with. I'm sure you are, because I'm sure that everybody in the world is familiar with it. Whether or not everybody in the world participates the same is going to be different. But have you heard of recycling things?
Yes.
Do you do it on, like at your house or yourself at school or anything like that? What kinds of things do you normally recycle?
Bottles.
So like water bottles and drink bottles and things like that. Anything else that you commonly recycle, or is it just kind of bottles?
Just kind of bottles.
It's kind of bottles, maybe
cans.
cardboard cans,
Cardboard cans,
things like that. What about you guys, Cece? You guys recycle?
Yeah, definitely a lot of paper and breakdown boxes.
Yeah. So do you guys have a blue can at your house?
Yes.
And that's where you put all the recycled? Yeah, we do that too. Now, did you know that there are some things that we consider recyclable that aren't actually recyclable? Did you know that?
No.
See, I was kind of amazed myself at the things that are and are not recyclable. So here we have some examples of things that we had laying around the studio, and courtesy of your mom in her pocketbook to take a look through some of the things right here. So the water bottle, I believe that is a number 2, right? The Tic Tac, do you remember what was on the bottom of that?
It was a 5.
A 5. And I know the hand sanitizer, right, was a 1. Mm-hmm. The small one was a 1. And the water bottle?
We got a 7 here.
A 7. So I think the camera is focusing in, because you'll always see those triangles, and inside the triangle there will be a number. And it has that universal symbol of reduce, use, recycle, which is the 3 arrows, right? And then we've got the other sanitizer, and that is a 5 on
I
there?
think we said it was founded as a 5.
Yeah, that was, yeah. All right, so anyway, we have those. So let's take a look at the different types of recycling here. So here we can see the different numbers that you would see on the bottom or someplace on the container. And we can see the water bottles that a lot of people do, soda and things like that, they're number 1s. Milk jugs, number 2, right? Shampoo, squeeze bottles, kind of things like this, right? Now these things, more food products are inside of these ones, right? And then we have not generally accepted. So the higher you go, the more difficult it is to recycle those products. And some of them can't even be recycled, right? So they've made them out of plastic so they become durable and less expensive to make, but you can't recycle them again, all right? So we can see here a lot of the different factors that go into whether or not you can recycle different products. So how to recycle? So when you recycle things, do you just take them and throw them in the blue can, or do you rinse them out and do that kind of stuff first?
You kind of have to rinse them out.
You rinse them out a little bit? Yeah, I mean, that's probably the best thing to do, because if you've got food or detergent or things like that, you kind of don't want that stuff sticking around, especially if you don't have a lid on it, and then you get all this stuff mixed up in your blue can. So it says if the product does not have the recycling symbol, toss it in the trash. All right, and we can see that the higher the number, more than likely it's not going to be recycled anyway. So it just saves on the processing and people going through that and stuff like that. So only 5% is actually recycled. Have you ever heard about landfills and oceans being filled with plastics?
Yeah.
Okay. Well, if only 5% of it is recycled, that means 95% of it isn't, and there's a lot of it, right? Because these are things that you see all the time, right? They're all made out of plastic,
Yeah.
right? And there's probably a lot of things that you use in your everyday life that are plastics, right? Mm-hmm. And most of it is not recycled. So I was looking, I forget what the stat was, but out of the millions of tons that are produced every year, there's only a very small percentage that is actually recycled. So, you learn a little something about recycling?
Yeah.
So I think the key is the lower the number, the easier it is to recycle. And that is today's Math in the News. All right, so out of all of these things, I think we said this was a 1, some 2s, a 5, and a 7. So what do you think would not be recycled here or recycled easily?
The 7.
Yeah, these ones probably, right? These would be the most difficult ones
Yes,
to recycle.
But
They are being able to be reused over and over and over
So
and
how
over
many
again.
bottles have we saved by
Well, it
using
depends
that?
upon how many times you use that.
Every day.
There you go. Every day. Now, I use this one every day, and this is courtesy of the Amplified podcast that left this as a gift for us one time. So since they left this here, and yeah, the Youth Voice Amplified. So wonderful podcast they have, and they were kind enough to come in one day and bring us that gift.
Saving them on plastic. There you go.
There you go. Hey, you know what? We've got a lot of kids in our, I guess, auxiliary studio, side studio, whatever, doing a little bit of science for Kern this afternoon.
Hi, welcome to Science Day on Do the Math, and today we have Chelsy from Science for Kern, and thanks for being with us today.
Of course.
So what project are we doing today?
Today we're doing chemistry in a bag, so we're going to have baking soda, calcium chloride, and a pH indicator in a bag, and we're going to do a little chemistry experiment, and I'm not going to say much more about it because I want the kids to make some predictions about what they think is going to be happening. So.
All right, so you guys have some baking soda on here, and what was the other one?
Calcium chloride.
And then we have the red is the...
Phenol, red phenol, the pH indicator.
So when you guys go to mix these, there's going to be some reactions happening, maybe some temperature changes, some color changes, right? So what do you guys think? Does anyone have some predictions they want to make? Yeah.
It'll fizz up.
They think it's going to fizz, okay. What about temperature-wise? You guys think it's going to get hot or cold? What do you
I
think?
think it's gonna get like a little bit hotter, like a little bit more,
Okay,
but not that much.
okay. Anybody else? What about color changes? Do you think? Yeah, what do you think?
It's gonna turn orange.
You think you're going to see orange? All right. Anybody else? You have a prediction? You don't know?
I'm just thinking right now.
You're pondering. Okay. Yeah. What about you guys? Not sure? All right. Well, so we have chemistry in a bag. We're going to do 2 projects, right? So we'll do this first project, and then they'll have a second project, right? That they'll get to kind of choose the reactions that happen, correct?
Yes, they get to design their own experiment and choose 2 of the 3 reactants that they want to put in the next bag and do a little bit of some experimentation to see how the other reactants work with each other. So, yeah.
All right. Well, we are going to let you guys get started on your math, and then when you come back to us, we will start our first project. All right. Back to you in the studio.
All right, thanks for that, Sam. Also, thank you to Chelsy for visiting us today from Science for Kern. In studio, we have Harrison, a 5th grade student from Stockdale Elementary, has been there since he started kindergarten, and you're going to miss your instructors when you move on to junior high. But you've been doing some great math so far. Now you're going to show us some of your expertise with fractions. All right, head on over to the board with Cece.
Okay, so go ahead and grab your pen. I'll grab one too, just in case. But I'm pretty much just going to leave it to you. Okay, where do you want us to start? You got a problem
Basic
for us?
knowledge of fractions. So first of all, draw a straight line, a fraction bar. Because that's the most common thing you're going to see with fractions, right? The numbers on top and bottom could be different all the time, but that's always going to be the same. So you can select what number goes on top and bottom and talk about if you know the proper names for those numbers also.
Okay, so the 3 is the what?
Numerator.
Fabulous. What about the 4?
Denominator.
Fantastic. So that fraction is called
3/4.
3/4. Nicely done. Okay, what does that mean?
It is 3 out of 4 parts.
Okay, good. Very nice. So if you, if we were to draw it, because this is something that might come up a little bit later. So I've got this box. Show me 3/4 of that box. Okay, good. So we know that we could call that, like just like you said, 3 out of 4. So 3 out of our 4 boxes are colored. I like that. Okay, very nice. All right, good. Shall we continue and move on to a little bit of addition and
Yeah, I was going
whatnot?
to say, we'll keep the like denominators right now. So if you can think of some of the types of problems you've been working on in class and explain one of those to CC, what you guys are doing right now.
So we've been doing like 5/9, like minus 2/9. and we would have to solve it. The denominators would stay the same, but the numerator would become a 3.
Okay, I like that. So our answer, your answer on that one is what?
3/9.
Okay, so let's go ahead and we'll just write 3/9 up here. Now, would you leave it as 3/9?
No,
Why?
because it can be simplified into a smaller number.
Okay, and tell me how.
You could do 3 divided by 3 would become, or 9 divided by 3 would become a 3, so there would be a 3 as the denominator, and then you would divide the 3 by 3, which would become a 1, so it would be 1/3.
Okay, good. So that's very nicely done. And of course, since we know that 3/9 is 1/3, if we had 1/3, we could go back to 3/9 as well. Okay, very good. So I like that. All right, so then let me give you another one. Let's do, since you did subtraction, let's go ahead. I'm going to come over here and let's go ahead and do the same thing. So 5/9 and 2/9, but this time we're going to do addition.
You do the same thing, but instead of subtracting the numerators, you would add the numerators. So it would be 7/9.
Okay, and why that changed color, I have no idea. I can't help you with that. But what didn't change was the denominator. Now, do we know why this works the way that it does?
Because it is like 9 parts out of 9 parts, but you're adding like 2 of them together. So it would keep the same amount of parts, but the parts are being added together.
Okay, I like that. Can we draw that as a picture maybe? We get that out of the way a little bit?
So it would be like, let's do rectangle and then, so that's 5/9.
Okay.
Or, wait. 7, 8. So we have 9 parts, and then I'll do the same thing. 1, 2, 3, 4, 5, 6, 7, 8. And then it would be 2.
You just get another line at least up on the top one, because you have 8
Let's see.
parts up on the
1,
top
2,
right now.
3, 4, 5, 6, 7, 8. Oh, yeah, okay. We need one more. Okay, good.
And then, just to make sure, just count the bottom again to make sure you're cool on that.
Yeah, okay.
Okay, cool.
So then you would do color in 5 of these. 1, 2, 3, 4, 5, and 2. So it would stay the same amount of parts, but if you put this onto that, it would still become, it would be 7/9.
7/9, very nice. I like that. Yeah, and the same thing when we did the subtraction. You would have colored those in, the 5, and then taken away 2 of them, which leaves you with the 3. Very nice. I like it. Okay.
So you guys are well on your way. So you've got
Okay.
about 2 more minutes. What I'd like you to do, Cece, is work on a problem where he's going to add fractions, but make it an improper when he's done with it.
Ah, sounds good. All right, so then let's give you this one. Let's do 4/5 plus 3/5. Let's see what happens there.
So you'd still add them, but it would become 7/5, and you would turn it into a mixed number because it is 7 out of 5. So it would be 1 whole, and then there is 2 leftovers.
Okay, very nice. So if we were to draw this again, I'll just throw it together a rectangular path. So you did rectangles. So 1, 2, 3, 4, 5, 6, 7. So, oh, I didn't want 7s. I wanted 5ths, didn't I? Wow, I blew it on that one. All right, so there's some 5ths. Okay, show me what it is that's happening there.
It is the 4/5 plus the 3/5. It is like 2 cakes being cut, but they wanted to save space, so they would put them together.
Okay.
But it would be 1 whole still, and then there would be some leftovers, so they would make a tinier tray to put the leftover 2/5. And then put the 2.
Okay, good. I like that. I like that explanation. Okay, very nice. Okay,
And you were speaking about cakes,
yeah.
right? This is something I'm going to, I need to borrow your
Yeah,
pen
you
for
do.
a second, all right? So let's say you have a birthday cake, all right? Now, when people cut a birthday cake, they usually go like this, right? And maybe you have a couple of pieces taken out, right? So this is the rest of the cake, but these two sides are open, right? They're open to the air, right? So have you ever had dried out cake or
Oh
something
yeah,
like
oh
that,
for sure,
right?
it's the worst.
Because sometimes that happens, right? So here's another way to cut a cake, right? So you take a slice out of the middle, right? And you can cut that into two pieces, or if you need another one, take another piece out like that. And when you're done, take the two pieces and smush them together. There's no open cake. Does that make sense?
Yeah.
Does that make sense to you?
It does. I
You're
don't know
like-
that I don't know that I like it.
What do you mean you don't like it? I don't know about you liking it or anything like that. I'm just telling you right now, if you want moist cake, you cut it out of the center, put the two pieces together.
If you keep cutting this direction though, and then you squish them, then you're gonna have like this big and then like this little small, and then it's just gonna.
If you cut them even.
Yeah. You're more talented than I.
Oh, well, you know, I've never done that. I just know about it like that. Ooh. Somebody don't like the cake, I guess. All right, anyway, some great problems so far this afternoon, Harrison. For doing some great work today, you've got yourself a meal from our friends at Grillenberger, so congratulations on that. So, I know that you probably use different manipulatives in class, things to use to understand math concepts a little bit. What are some of the things that you've used? Can you think of any of those things?
For decimals, we've used like those foam blocks.
Okay, so you use blocks and things like that, rulers, protractors, compasses, and things like that. Well, another one that they use is dice.
Hi, I'm April.
And I'm Zenaida.
Today we're here to talk to you about dice. There are just the 6-sided dice here that has 1, 2, 3, 4, 5, 6, and it's good for students to use in identifying numbers, subitizing, adding, subtracting, even multiplying. They've come up with a new creation where there's dice in dice. There is a die inside of a regular die, so a normal die inside of a plastic colored die. So there's dice and dice. What you can do is you can use several dice at one time, and you can use this for roll them, set them, and have students count, subitize, order, compare, which is larger, which is smaller. You can buy a clear plastic die that's non-colored, and then you can put things on them. So I've put some shapes on this die, and in primary grades we can see if they're the same or if they're different. Here we have a 12-sided die. And what are some uses for a 12-sided die? What do you think?
We could build numbers with that as well.
Okay. So building numbers, we can also add and subtract. So there's another way that we can use die. And then we have a 10-sided die in which we can do the same types of things. So we've got 5 numbers on one side and 5 numbers on the other side. When you're in 3rd, 4th, and 5th grade, we've got fractional die. So with the fractional die, students can compare, they can order, they can add and subtract. So there's different things that you can do with dice. Today, Zenaida and I are going to play a game. It's called Dice War, and each of us has 5 counters and 2 dice. So we got some plastic or some foam fun die, and so what we're going to do is we're going to roll the dice at the same time, and then we're going to add what comes up. And whoever has the larger number gets to take a counter from their partner. And it's like Dice War. And so whoever ends up with the most counters in the end is the winner. So you ready?
Yes.
Okay, let's go. I have 2 and 1 for 3.
I have 9, 6, and 3.
Which counter would you like?
The blue one.
Okay, one more time.
Oh, I have 6 and 5, makes 11.
I have 6 and 3, that makes 9. My counters are going away. Last one more time. Oh!
I got double.
And
6
who might
6.
win war? And so that's Dice War if you'd like to play a game with the kids or have this in a math center. Another game I'd like to show you is called Block Out. So we're going to use the die and die because there's a die inside of the die, and a graph, and this is a 10 by 10. And what we're going to do is block out. We're going to multiply outside die by inside die, and then we're going to create an array and a multiplication sentence. So I'll go first. That is 2 and 4, so I'm going to go 2 by 4. So my multiplication sentence would be 2 times 4 equals 8. And Zenaida, your turn.
I got a 4 on the outside and a 1 inside,
So let's be strategic in where you place this because we want to fill up the whole grid.
I want to fill up the whole grid. So I know I can only do 4 times 1, but do I want to do 2 times 2? Could I do
No,
that?
you have to do 4 times 1 because you have to make a 1 by 4. Only if you roll a 2 by 2.
I know.
That's a great question.
4 times 1 equals 4. But friend, before I begin my next roll, I noticed that you said 2 by 4, but you have, looks like a 2 by 3 here.
Oh, so I need to add. So then this is actually my 2 times 4 equals 8. Thank you.
That's okay, friend. We all make mistakes and we learn from them.
All
so let me
right.
go ahead and go again. I have, oh no, 1 times 2. 1 times 2. 1 times 2. Better luck next time. That's just,
Okay,
and
well-
I'm not happy about it because I want larger numbers so I can get a larger area here to
Well,
cover.
let me see what I get. I have a 6 by 2, so I'm going to be really careful. And I'll just start here because I know that that's 2. So I'm going to count 1, 2, 3, 4, 5, 6. You think that's good?
That's so small.
Yeah, so I know that this is 10. This time I got 6, last time I got 4, so that is good. 2 times 6 equals 12. And then we would continue to roll alternately to check to see, to fill the entire box. And then it becomes more strategic later. And then we can see who has the most covered. Will it be green or will it be pink? And that will be how we end our blockout game.
That went from A to Z.
Yes, it
April
did.
to Zenaida right there. See, I got you on that one. Yeah, all right. So you see with the buzzers today, the lack of the love for cake and the A to Z thing, you guys didn't get that. Did you like that one? I thought that was pretty good, right? The two girls were April and Zenaida, right? You're
I
doing
just
pretty
figured
good?
you were having like every single thing you could do with dice. So that's,
All right, so have you given any thought as far as what you might like to do when you are through with all of your schooling, as far as an occupation goes? Well, you're only in fifth grade, you got plenty of time.
I
But
want to be a geologist, kind
a
of.
geologist, all right, so you like science.
Yeah.
All right, so you're going to want to, right now, ideally work in geology, all right? Do you think there's any other science classes you'll have to take during high school before you do that in college? What kinds of things you might need to take? You ever heard of biology?
Yeah.
I'm pretty sure you're gonna have to take that. Have you ever heard of chemistry?
Yeah.
I'm pretty sure you're gonna have to take that. But right now, we're gonna learn a little bit more about chemistry with Chelsy and Sam down at Science for Current.
All right, welcome back. So the kids are about to begin their first experiment. All right, so Chelsy, walk us through the steps.
Okay, so you've been looking at the chemistry in a bag handout, right? So you kind of have an idea. But we're going to be putting one of the powders, the calcium chloride rocks, into one corner of the bag. And then we're going to put the baking soda, which many of you said you're familiar with, right, on the other side of the bag, keeping them as separate as you can. And then you're going to put your red phenol. How much of that are we going to add? 10 milliliters. 10 milliliters, exactly. So you're going to carefully pour that into here, put it into the cup first, and then you're going to gently put the cup into the middle of the bag, just like you see in the picture. Okay, so you're going to set it in there, and you can hold it at the bottom here, keeping the powders separate. Seal it completely, and then you're going to dump it over carefully, keeping everything separate, and then you can start your observations. So I like to use the words I notice and I wonder. So as you are feeling the bag and looking at it and observing everything happening, you're going to say what you notice and wonder. Okay? And then you can get started now. So let's see how well you do getting this set up. All right.
I think we should put like this one. I think we should put the cup in first so we can like separate it.
No, I don't think that's a good idea.
Can I see that? You do it. Can I see that?
So the cup, we probably want to keep it out because you're gonna put the liquid in it outside of the bag.
But if we put the cup in first and like we separate it, you can just take the cup out and put the liquid in it.
I know, I just don't want you to spill the liquid on it on accident, you know?
Oh, never mind, I got it.
You're good. You got it. We're taking turns, you got it. Okay, looking good over here.
That's about 10. Right? That's a little bit over 10.
Nice, you got it on both sides. All right, then we're gonna slowly pour that into here, up to the 10.
I love watching people do science. It's my favorite thing.
Almost there. Yeah, that's good. I'll give them some. I'm not gonna touch it, but you can pass that to them. Gotcha. 2 cups here, huh?
Oh, shoot. Yeah, there are 2 cups. But you don't do it like that, you have to put it in. Can we seal all that shut?
Seal it shut completely before you spill it.
There you go.
Or shut it?
You think you're ready? Yeah. Okay. And make sure you seal the bag. That's why we sealed it up.
Just to 10.
Really open fast.
It's that's
Okay, you ready to start? That's okay, yeah. Okay. And make sure that you're feeling it the whole time, making observations.
Okay, mine is on there. This is cold.
gonna pour that one into that one.
Can I see that? I tried to spill this much. My thing's on it.
Okay.
It feels like it's on your hands. So this one, the red's cold and the yellow is hot. Whoa, really hot.
That looks
interesting. It is.
Okay, seal your bag up before you're gonna get in there.
Lumber. Is there a name for this?
Hey, here it is. Was right.
Oh, the bag might pop. I'll make sure it's hot. It's hot. Yeah, it gets hot. It's really hot. I thought it would be like wet, but it's hot.
Make sure you close it first before you tip.
Well, it's burning.
Is it?
Which side do we tip it over? It shouldn't burn a hole through the bag. I'm gonna shake it.
All right, so you guys are now starting to make your observations, right?
You can open up your bag now to release some of that gas. No, open up the bag to release the gas that it's
We
creating.
can't pop it? Wait, can I just let it be like this?
No, we do not want to pop it because then everywhere.
Can I just let it be like this?
It's gonna keep going. You might want to.
Okay.
Hey, how's it going over here? Oh, look at that color.
I don't think I added enough.
You got a really bright pink right there.
So like the bright pink one. I put way too much
Okay.
brown here. That's not good enough. I didn't put enough. I didn't put enough calcium. But no, not calcium.
So what's making it blow up like this?
So the fizz, it releases gas.
Yes.
The gas makes it blow up.
There you go.
I noticed it's warm. How do you guys have red?
Warmer in the corners?
Yeah. How do you guys have red? I don't feel any. I only have yellow.
Are all your rocks gone now?
Yeah, yours don't seem to be having as big of a reaction.
So you guys said yours.
Cooler, but it's still
So you said yours was warm, right? And you said it was what kind of reaction? Endothermic or exothermic?
Can I put it in endothermic? No,
And exothermic was when it got hot, and endothermic was when it got cold. Yours blown up.
Yeah, but the heat is over
So I
the
just
whole.
dropped one of these balls in you.
All right, so this is our first experiment. We have one more experiment that they're going to conduct, and we will see that in just a little bit. Back to you, Mike.
All right, thanks for that, Sam. Also, thanks to Chelsy. A great thing that they've got going on down there with the chemistry, and a lot of reactions down there, right? Chemical and from the students also, right? What has made you think about geology? Do you like collecting rocks, or have you been someplace that sparked an interest in this?
I like collecting rocks.
Do you have a particular type that you like, or just kind? Do you know the different types of rocks, like sedimentary, metamorphic, things like that?
Yeah.
All right, cool. You know what a volcanologist does? That's something for you to look up over the week, but they have something to do with rocks also right there. Anyway, you ready to get back to work? All right, so you've been doing some fractions with like denominators, so now you and Cece are going to work with unlike denominators.
Okay,
all right?
so let's go ahead and I'm going to give you, we'll just do this. So 1/2 plus 1/3. So what are we doing here?
So you would multiply these, so that is 6 and 6. And then you would multiply the 3 with 1, which is 3, and then the 2 with the 1, which is 1.
No, try that one
Or
more
2.
time. There you go, there you go.
And then you would add those together, which equals 5/6.
Okay, good. Now, why? So let's talk about cakes again, right? So if we're talking about cakes and we say, oh, I want half of a cake, and then I say, oh, I want 1/3 of a cake, right? So this is my 1/3 of a cake, here's my half of a cake. How much cake did I just cut up? 1/2 and 1/3. Well, I gotta figure out a better way to say that, right? I gotta figure out a better way. So we say, all right, my 1/2 and my 1/3, what are some great ways we can cut that up so that we can talk about them in a similar way, right? So we say, okay, well, if I cut my 1/2 into 1/3s, right, I know that I've got 1/3s over here as well. So I now have 1, 2, 3, 4, 5, 6 pieces, and that's why we can do it that way. So we've got the 1/2, which, like you said, was 3, 6, so there's 1, 2, 3 of my 6 pieces. We had one more 1/3 over here, right? So, well, 1/3, sorry. So our 1/3 we also cut into 6ths. So we cut it that way, so we've got 2. And so here we just have this one little remainder of 1/6 that isn't our part of our cake, but we have 5/6. So that's why we have to have our common denominator. So we have a way to talk about it, right? Instead of a 1/2 and 1/3. Yeah? Okay.
So do this one, Cece, where
Yep.
you've got the denominators of 4 and 12.
Okay, all right. So then we're
Because
gonna move
he just multiplied the 2 before and got 2 times 3, but
on. Right.
how there's a different way instead of always multiplying.
Okay, and I'm just going to keep it nice with the 1/4 and 1/12. Okay, so what's our common denominator this time?
1.
Our common denominator. So if we're looking at our denominators, the 4 and the 12, what are we going to use as our common denominator?
3.
3. What do you mean by 3?
2.
Not good. You can kind of go with me on the 3. I'm okay with it. Talk to me about why you were thinking of 3. Why did a 3 even pop into your head?
Because 4 times 3 equals 12.
Okay, nice. Okay, so we know really our whole goal is to get a common denominator. We don't have to multiply them to get 48. We don't need to go that big. We don't have to cut our cake into that tiny little pieces. Instead, we can stay there, right? So go ahead and show us.
We could do 2.
No, stick with exactly what you said with the 3, right?
Right.
Mm-hmm.
So you would multiply both of them by 3. So it would be 3 times 4 is 12. And then 3 times 1 is 3. So then plus, and then 12 times 3 is...
Oh, wait,
So
wait,
that's
wait,
where
wait.
I'm going to let you guys keep going right there. I'm going to let you guys keep exploring that for a moment.
Okay.
But while you guys are doing that, we're going to learn a bit more about one of the CSU schools.
Welcome to Cal Maritime, the most unique campus in the California State University system. There are several reasons why I chose California State University Maritime Academy, but I'll start with one. Located on a scenic waterfront campus in Vallejo, Cal Maritime is one of only 7 degree-granting maritime academies in the United States, and the only one on the West Coast. About 71% of the Earth's surface is comprised of water, making the maritime transportation industry the backbone of international trade and the global economy. By training the next generation of mariners, engineers, scientists, policymakers, business professionals, military service members, and global leaders, Cal Maritime is positioning the state of California for for economic vitality in America's Pacific century. We have the highest employment rate in the CSU system. Simply put, we are answering a greater call to help build our nation's future by land and by sea. Here, intellectual learning, applied technology, leadership development, and global awareness are our 4 compass points that symbolize the key elements of Cal Maritime's commitment to educating and preparing cadets for the future. These values, paired with the dedicated work of our faculty and staff, prepare cadets for the world, and prepare the world for cadets like us.
My name is Kalai Pratt. I'm born and raised in San Francisco. I'm currently an International Business and Logistics major, or IBL for short. I chose Cal Maritime because I wanted a place that would set me above and allow me to practice my leadership opportunities. At Cal Maritime, we're challenged to think critically and independently. Our smaller class sizes ensure we get the individual attention we need with our faculty. As the demand for maritime industry professionals grow, Cal Maritime continues to consistently produce skilled leaders who are ready to step into leadership positions upon graduation in order to answer the call and solve for an ever-changing and sometimes uncertain future.
My name is Kai Kraus. I'm from Oxnard, California, and I'm studying Facilities Engineering Technology. One of my favorite things about Cal Maritime is the learning I get to do outside of a traditional classroom. Learning isn't just happening in the classroom, but out on ships and vessels. So we get the real hands-on experience with the latest technology that is being used in our respective fields. It is instilled in cadets early on that you'll be a lifelong learner and problem solver who can use your knowledge and skills to solve not only the current challenges, but the challenges that are yet to present themselves.
My name is Ryan Okada, and I'm from Oakland, California. I'm studying marine transportation and hoping to sail on an American vessel. I currently serve as the president of ASCMA, which is the Associated Students of Cal Maritime. If you haven't noticed, we wear uniforms. It's part of our campus culture as the Corps of Cadets, which encompasses our student body. Our uniforms are a physical representation of our commitment to each other as cadets and help foster a sense of belonging and equity. But it's not just about uniforms. Since 1929, Cal Maritime has been developing leaders. Participation in the Corps of Cadets, athletics programs, and the Edwards Leadership Program helps to develop self-discipline, self-esteem, and character, which is critical for success and is a vital part of our campus culture.
My name is Anjali Sharma. I'm from Fullerton, California. I'm studying international business and logistics, and I'm preparing for a career in the United States Marine Corps, hopefully going to commission as a second lieutenant. I know Cal Maritime has offered me opportunities to be a global citizen. In my time here, I've studied in Morocco, Japan, and India. All cadets are required to travel abroad in order to graduate. It's one important way Cal Maritime makes sure cadets leave with a global perspective. We gain valuable experiences either on summer cruise aboard the training ship Golden Bear or on non-school study tours around the world. Cal Maritime sponsored 3-week study tours to international locations such as Costa Rica, Vietnam, France, Morocco, and Northern Europe. Provide our cadets with a valuable exposure to the business environments and political issues around the globe. Whether you're working shoreside or at sea, you have to have a working knowledge of international politics and economics, environmental and cultural awareness, and global dynamics.
We are California State University Maritime Academy, defined by this system of beliefs that makes us unique as an institution of higher education. Because, as our motto states, to work, to fight, we are ready.
Another great school in the CSU system, Maritime right there, and you gotta love the water if you want to go there. A lot of things to do right there. Harrison wants to be on land, geologist, right, so far right now, but you guys are working on fractions with unlike denominators, so tell us where you're gonna go with this now.
Okay. So it would actually stay 1/12 because the goal is just to get same denominator.
Perfect.
So then you would add it, which becomes 4/12.
Okay, we gonna leave it?
No, you would simplify it.
Okay, I like it. Go ahead.
It would be 2 is the greatest common factor.
Okay, go ahead and do the division by 2.
So you would divide by 2 and divide by 2, and this would equal 2. and this would equal 6. Oh.
Oh, we can go further. But you know what? That's okay. We can just keep going. Go ahead.
You could do 4.
You're
So
right. We
then
could have
if
done
you
4, but that's okay.
If you do 2 again, it would equal 1 and 3, so 1/3.
Nicely done. Okay, good. So we're going to move on, and we're going to do this, and I'm going to leave it with just 1 over. And talk to me again about common denominators.
Okay, so to make these equal, the lowest thing that eventually will be the same is 30, and you would have to times that by 5, and this by 3.
Good, because we're always talking about multiplication. So we're saying what multiplies to get us to something that's the same. So you said 30, so go ahead and show us.
So then this would be 30, and this would also be 30. And now you would also multiply this by 3, which would be 3/30ths, and that by 5, which becomes 5/30. So then you would add it, which becomes 8/30ths.
Nice.
And then you would divide, let's see, 4 when we're 2.
So what are you thinking? What are you thinking while you're kind of going through some stuff? What are you doing?
You have to do the greatest common factor.
Okay.
4 would work with this, but not with that.
Okay.
And so you could.
Now, again, so you're talking about wanting to jump straight to the greatest one. Do you have to jump to the greatest one?
No.
Okay, so what do we know we can divide both of those by?
2.
Because they're both even, right? Okay, and then if magically we can do more, I say magically, I don't mean magically. If by mathematics we can do more, we can do more, but we know 2, so let's just do 2.
So divide by 2, divide by 2, that would be 15. This would be 4.
Okay, can we go further?
No.
No, we can't, because one's even, one's odd, and they got nothing else. Okay, so we're good, so we're done. And that is?
4/15.
Nicely done. Okay, I like it.
I'm going to give you guys a minute to get started on one more if you would like to.
Okay.
So instead of the 6 and 10 where you had to turn both of them, let's do 3 and 9.
So those are our denominators?
Correct.
Okay, so we can just keep it in 1 and 1? All right.
Okay. So for this one, you could do with the 4 and 12, you could just multiply it by 3. So you would multiply this by 3, and that would be 9. And then you would multiply that by 3, which would also 3. So then you would put the add, and then that would stay 9. This would stay 1. So then, those equal 4/9.
Okay.
And those cannot be
You
simplified.
can't simplify it? No. Okay, you're right. I like it. I like it very much. Good. Good, good.
There you go.
Good, Mike?
Nicely done. So you're well on your way to working with fractions with unlike denominators. Before you even do it in class, you'll have kind of a head start on that, right? All right, there you go. 636-4357 is the phone number. We do have phone tutors most Tuesdays and Wednesdays throughout most of the regular school year, between 3:30 and 5:30. Coming up soon, actually in a couple of weeks right after Thanksgiving, we'll be giving away tickets to go see Holiday Lights at COM. Once again, actually walking through COM this year. But right now, we're going to go back downstairs, check in with Sam and Chelsy, and see what's up with Science for Current.
Okay, welcome back. We're back with our final experiment. So Chelsy, what are they doing next?
Okay, so this time they get to choose one or two of the 3 reactants and do their own little experiment in another bag. So the idea is just to hone in on one of the experiments and do a little bit more observing to see what goes down when you mix 2 of the 3.
All right, so which 2 are you going to pick? Baking soda and the red phenol? Is that what it's called? All right.
Yeah.
All right, let's see what happens. Go for it. Don't look if you're doing this one. All right. Go get that 10 milliliters. pour it in. All right. Zip it up first and start squishing it. See what you feel. And then color changes, temperature changes.
It's pink.
It's pink. But what about temperature? Is it changing? Is it cold? Is it hot?
I don't know if it changed, but it feels cold.
It feels cold. All right. Okay, what about you guys here? Which ones are you picking?
I picked the calcium chloride and the red stuff.
Okay, I'll try that. What about you? Which two are you gonna pick?
The same.
All right. You guys can both go for it. You guys going ahead and getting your phenol poured in? Does it feel colder? I'm probably not supposed to touch without gloves. Oh, it is cold. So then here you can say the reaction of blank and blank caused a, I think it's an endothermic reaction, right? All right, you got your phenol. There you go, that's good. All right, let's see what's gonna happen. Are you guys gonna do it together? You can just pour it straight in. 3, 2, 1, go. All right, zip it up. All right, what's happening?
Really hot.
Is it?
Oh yeah, it's kind of like the stuff they do in hand warmers.
Oh, that's cool. So it's exothermic, right? Hot is exothermic.
And they're also turning pink.
All right. Oh yeah. All right. Let's move over here. What'd you guys choose?
I chose the calcium chloride and the phenol red.
All right. So you guys are all going with that. All right.
Yeah, we might
Okay.
need a little bit extra. We've got a lot.
Here, you can use this one.
Yeah, you can use that.
Yep. Yep. Go for it. Pour it in.
I'm gonna try mashing this stuff up and see if it makes a difference.
Oh, all right.
There we
go.
go.
Oh.
More surface area.
Oh, you got some bubbles going with yours.
Ooh,
Oh, and orange.
Oh, I got a
Oh, look at
Radiant.
yours. Yeah.
I don't think that was a good idea because now there's a hole in this bag.
Uh-oh.
no.
Yeah. Maybe don't pour anything in that one.
Oh my lordy lord. I guess I'm
So
trying
you guys have
it's
some more
burning.
reaction happening with
More.
yours than they
You
did.
can transfer.
More liquid.
Huh.
And it
Appears that the
So did you have less rocks than they did or more liquid?
I don't know.
Is that something that...
The amount could affect it.
Okay.
now it's red.
Interesting.
Mine's like really red.
Oh, look at yours.
Mine's burning.
Yeah. Is it really hot? Oh, wow.
Oh, it's hot.
Dang, that is hot.
I'm trying to
Well, look at yours, and yours is all
Whoa,
yellow.
whoa, whoa. Mine's all red.
You got a hole. All right, last table. Which one are you guys doing?
We're both doing
Calcium chloride.
All
All
and then
right.
they're gonna need the powder.
Okay, let's see it. Go for it.
Mine's gonna have to get a hole.
You guys, who's doing the powder? You guys can go ahead and start putting the powder in. You guys can all do it at the same time.
I think we're gonna need more phenol red for one of them though, because we only.
Okay.
Okay.
Well, you already have some.
Yeah, but then we have.
Okay. Oh yeah, pour yours in first, and then we'll see.
It's getting like burning, like blue red.
Okay.
The rocks.
It's been interesting with the different amounts that they're using. We're getting different reactions. How about yours?
I put some yellow.
But it's more red.
Oh, but yours is starting to build up that gas too.
Yeah, last time it's different. Last time it was really busy.
Mine's starting
It's
to
really
really
hot.
Okay, you guys got a lot of reactions going on here. All right, so Chelsy, if a teacher wants to do this project in their classroom, how does Science for Kern help them out?
Okay, so Science for Kern has a lending library, so it's a place where you can rent out science kits, and they will be delivered and picked up by our Science for Kern team, so you can do science for free in your classroom, just like this. So
That
yeah.
is so awesome. Well, thank you, Chelsea, and
you.
thank you, Science for Kern, for all the wonderful projects. Until next time, back to you in the studio.
All right, thanks for that. Science for Free from Science for Kern. In studio with us, we have Harrison, and you've been doing some great work today. Was it a little windy on the way into the studio today?
Yeah.
Yeah, but not hurricane wind.
Hurricanes are very large and intense storms. But where do these giant storms come from? A hurricane starts with the warm water found near the equator. Hurricanes typically only form in tropical regions where the ocean is at least 80 degrees Fahrenheit. These warm waters evaporate, creating warm, moist air which acts as fuel for the storm. Wind is also needed for a hurricane to form. Many hurricanes in the United States are caused by winds blowing across the Atlantic Ocean from Africa. This wind causes even more of the warm water to evaporate into the air. The warm, moist air then rises high into the atmosphere, where it begins to cool. Way up there, the water vapor condenses back into liquid water droplets. Water droplets in the atmosphere form clouds, including big, stormy cumulonimbus clouds. As the warm air continues rising upward, the winds begin blowing in a circular pattern around a center. The spiraling winds gather up a cluster of big thunderstorm clouds. Once the spinning winds reach 74 miles per hour, the storm has officially become a hurricane. Hurricanes are huge. They can be 10 miles high and over 1,000 miles across. Once a hurricane hits land, it runs out of warm, moist air and its winds begin to weaken. But the storm can still cause lots of damage to communities near the coast. Thankfully, we have weather satellites that are constantly monitoring the conditions down here on Earth. The GOES-R series of weather satellites scan the hemisphere every 10 minutes and the US every 5 minutes, keeping an eye on conditions that might cause a hurricane to form. Once a hurricane forms, the satellites can help predict the storm's intensity and track it minute by minute. This information allows meteorologists to deliver early warnings and help people stay safe. Find out more about Earth's weather at NOAA's SciJinx.
And I've got to admit, that's one thing I'm glad that I don't live near is hurricanes and hurricane season, things like that. So in California, we've got the earthquakes every once in a while. But anyway, more importantly, did you learn a little something today, Harrison?
Yes.
Did you have fun?
Yes.
Good. You know what I dig? I dig that hat. Can I see that hat for a moment? You think the old man looked good with a hat on? Maybe. All right. I don't know about this being the right size. All right, I finally got a ding-ding there today, all right? Instead of always getting buzzed and stuff like that. Thanks for that. Maybe I'll sport a hat like that. Keep my head warm in the wintertime. Anyway, we do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.